Okay. Good evening, students. Welcome to our last revision lecture. We have about 30 students so far. Hopefully, more will join us as the session is going on. I'm going to stop my camera and go to the lecture slides. Can you see the lecture slides? Can somebody please confirm?
Yes.
Okay. Now, we're going to study the last portion of engineering programming, and this last portion is a revision of what we have been studying since the beginning of our lecture session before the lockdown and after the lockdown. What are the things we studied? So let's do a quick revision of the things we have studied. Okay. If you have not given feedback on evaluate, please do so. Your feedback is very important to us. The feedback has got different aspects, okay, different questions, and on those questions you have to reply whether you strongly agree or just agree or disagree, strongly disagree, or if you're unable to choose, then you select unable to judge. So here we are, the last lecture, a revision lecture. What did we study this semester? We studied C programming fundamentals, we studied control flow, we studied looping structure, we studied arrays, matrix, and data structure. And finally, we ended it all with functions part 1 and 2, and finally with file input and output. And these concepts we have already implemented in our assignment, okay, which is due on 5th. Now, let's go through these topics once again, okay? As far as C programming fundamentals is concerned, this is something we have studied before the lockdown. We those of you who came for the lecture session, uh, you got a good idea about what is the fundamentals. Nevertheless, let's go through them again so that it will be a revision for us. And while we are doing this revision, my dear students, you can look and see whether you have implemented this in your assignment. If you have not yet implemented, find ways and means to go and update your assignment. We have some students who have already submitted their assignment. Yes, you'll be surprised. There are some students who have already submitted their assignment. Okay. Now, the first thing we studied was identifiers. If you want to write a program, the first thing you have to do is have identifiers in the form of a variable or a constant. Okay. The first thing you have to tell your program is, hey, I want to store data in my program. So this is my data. This is the data type of my data. And this is the value stored in the data. Okay. You just have to follow a few rules that it should be alphabetic characters, digits, and underscore. And the first character of a variable cannot be a digit. Okay. Now, a variable in a program is very important. Without a variable, your program pretty much cannot do much. It can only display. Okay. Now, look over here. We have got some valid variable names and we have got some invalid variable names. Okay. Right over here, you can see a variable name that starts with two names. Since it starts with a number, it is invalid. Here, you cannot have a space. Here, you cannot use a reserved, name. This is for a reserved word. Okay. There are certain reserved words in the C programming language that we cannot use as variable names. And in your assignment, they have told you your variable names should be self-descriptive, should tell what you're going to store inside it. So give a valid name to your variables in your assignment. When you create a variable, you have to mention what is the data type of the variable. We have got many data types, but the fundamental amongst them are integers, decimal point, which is floats, and characters. Characters are enclosed in single quotes. Besides that, we also have short integer, long integer. We have got double, which is just like float, but it can store more precision decimal points. And we also have strings. Strings are enclosed in double quotes rather than single quotes. Now, string, you can create a string inside your C programming language. Remember, in C programming language, there is no separate data type as a string. You have to create a string or store a string by creating something known as an array. What is an array? An array is a special variable which has got a dimension. What's the meaning of dimension? It means a size. Okay? So here I'm creating a variable known as name, and the size is 50. That means it can store data consisting of 50 spaces. And each subscript has got an address. So here, the first subscript address is 0, and the last subscript address will be 49. Okay? So you see over here, I'm storing data inside my array. Okay? Except over here, there's a mistake. It shouldn't enclose in double quotes. It should be single quote, single quote, single quote. Double quote is only when we have a string. Constants are just like variables except one small difference. Okay? A variable value can change inside a program. If the beginning you give a value, in the middle you can do calculations and change the value of a variable. But a constant value, once created, cannot be modified. Okay? This is the way you can create a constant, either in this way or in this way. Now try and find out in your assignment, where can I create a constant? Just implement a constant inside, another feature that you can include in your assignment. Remember, my dear students, in your case, you are special. Okay? You have not given the midterm exam, you have not given the final exam. Instead, you have been asked to create an assignment which is going to have all the features of the topics that you have studied. Okay? So you have to find out which concepts I can take from these topics and implement it in my assignment. That's why I kept on telling you it's not an overnight assignment that you can do in one day. You have to plan, you have to work on it. Okay? We also studied about arithmetic expressions that you can include in your program. Addition, subtraction, multiplication, division, brackets. Okay? It follows the BODMAS rule. You can have unary operators to increment by 1 or decrement by 1, and so on. We also have math inbuilt functions, system functions. Okay? Whenever you use all these functions, any one of these functions you want to use, you have to have a math.h header file. The library over here has got information about all these functions. And in Linux, when you want to compile your program, you just have to type -lm when you're using math.h. only in Linux. We also have Boolean variables. Okay. Can you all hear me? Can somebody confirm that they can hear me?
Yes.
Okay, fine. We also have Boolean variables. Boolean variables represent either true or false. Okay, usually false value is 0 and true is 1. You can define a Boolean variable like this. We also have special variables, also known as comparison variables, which result into Boolean values. Okay. First of all, we have got the logical uh, operators, not variables, sorry, operators, which are and or. We also have comparison operators, same as, not same as, greater than, less than, greater than or equal to, and less than or equal to. And whenever you use this in your program, you are evaluating to a Boolean true or false. Okay, it can either relate to a true or false. If it is true, it will do certain action. If it is false, it will do some other action. Next topic we went through was control flow. The concept of if, then, else, and the case construct. Okay, the simple concept: if this condition is true, do this line of action. Otherwise, go to the next line of code, or else do this line of code. We can have a single branch of if condition. If the condition is true, it will execute this line. Or dual branch. If the condition is true, it will execute this. If the condition is false, it will go to else. Okay? Like I said, my dear students, in your case, you're very lucky because you don't have to do an actual exam and write code. Okay? You are being tested on the assignment in applying the knowledge. Okay? So I hope you have taken advantage of this situation and done your assignment very well. You can also have nested if condition. Look at this. If the condition is true, it will go inside the if condition. You see the if condition has got curly braces. Opens here, ends here. If this condition is true, goes inside and tests this if. If this condition is true, then it executes this statement. On the other hand, if this condition is false, it doesn't go inside if and just goes to the next line of code. Now, you may omit your curly braces completely, like in this case. If condition is true, then it will go to this if else. This else belongs to this immediate if. Okay. However, if you want this else to belong to this if, you have no other recourse but to use curly braces. For those of you who have done your assignment, my advice to you is to improve your program's readability. Please use curly braces. Okay. So this if else is under this if. So this else belongs to this if. So you can also distinguish by using curly braces, like if this condition is true, it will execute and go inside. Once this condition is true, it will execute this. If this condition is false, it will go to this else. So this else belongs to this if. Look at the last example. If this condition is true, it will go and execute this line of condition. If this is true, it will execute this. On the other hand, if this condition is false, then only it will go to this else. So this else belongs to this if, not this if. How does the compiler recognize this? Because of the curly braces. Okay. So similarly, I hope you have implemented this in your assignment. We also have chained if-else construct. Okay, so where you have if condition, then you will have else if, else if, else if as many times as you want. And at the end, you can have a else. Remember, else does not have a condition. Whether you want to have an else at the end, it is optional depending on the situation. We also studied about the switch case construct. For example, convert a student mark between 0 and 100 to a grade as below. Okay, so how did we do it? The first thing we did was 0 to 100. We want the value between 0 to 10. So we divided the mark by 10. Okay, we intelligently declared the variable mark2 as integer. Why? Because if there are any decimal places, we don't care. It will just omit those decimal places in this division. Correct? And then using a case construct, we said if the case is between 0 and 4, show fail. If the case is 5, show pass. 6, credit. 7, distinction. 8, 9, and 10, high distinction. Okay? Usually we can use a switch case statement to create a menu. We can create a menu by using if-else construct. Okay? In your assignment, you have to create a menu, right? So you have to know how to implement it. Another example to check if an integer value is even or odd. Here we have an example of an algorithm in the form of a flow chart. So we input the value. If the value is even, it will show yes, it is even. If it is not even, it will show it is odd. Okay? Now, how do we implement that in an actual program? We use the modulo operator. The modulo operator shows us the remainder of a division. For example, 5 modulo 3. What does it mean? That means divide 5 by 3. 3 times 1 is 3. Remainder is 2. So 5 modulo 3 is the same as 2. Okay? So 5 modulo 3 is 2. Remember, a modulo operator always shows you the remainder of a division. Now that we have this knowledge, we can find out whether a number is even or odd. If the number is divided by 2 and the remainder is 2, that means it's an even number. Else, the number is odd. Next, we studied the concept of loop. The concept of loop taught us that sometimes we need to execute a section of code repeatedly. This helps our program become more efficient. Okay? So, as long as we execute the code repeatedly and at some point we get out of the code, then we have an efficient loop. If we don't get out of the loop, it becomes an infinite loop and becomes a dangerous virus. Okay? So, implementing loops, we have got for loop, do while loop, and while do loop. All these loops can be interchanged, but they are usually used in a specific place and for a specific reason. Now, if you remember, this looks so much like your assignment, doesn't it? At least there is some reflection of this inside your assignment. An engineer is responsible for recommending a certain size of pipe for a new plant. The internal radius of the pipe can vary between 10 and 50 cm in steps of 5 cm. So it starts from 10, the radius, okay, and then goes to 15, 20, 25, and so on. The size of the pipe is dependent on the volume of the liquid flowing out of the pipe in meters cubed per second. Okay, so we have to create a program to show this. Now, if you want to show from 10 to 50 in steps of 5, So that means it has to go through 9 iterations, okay? Or rather, over here, if you observe the 9 iterations that we are talking about, how do we create it? There are different ways you can create it. You can say I is equal to 0, I is less than 9. So from 0 to 9, that is 0 to 8, that will be 9 iteration. Or you can say I is equal to 1, I is less than or equal to 9. Different ways you can do it. So the loop works in this way. As long as the condition is true, this loop will continue. That's why they call it a loop, a cycle, iteration. The moment this is false, what you can do, the moment this is false, it will get out of the loop and your loop cycle will be complete. Okay? Like I said, you can create beautiful viruses by using a loop. You can create an infinite loop that, for example, opens something which takes too much space, like Microsoft PowerPoint. Open Microsoft PowerPoint, put it on an infinite loop, and once you run that program, your computer cannot do anything else. It will keep on opening PowerPoints. So create a program like this, put it in your email and send it to your friend. Okay? That's a joke, my dear students. Don't do that. Your friend will curse you. Now, here, I'm using a while loop. Okay? A while loop will execute the condition first. If the condition is true, then only it goes inside and executes the statement. We also have a situation where sometimes we want to execute the statement first and then the condition. In those cases, you use a do-while loop. Okay, using a do-while loop, it will execute the statement, then the condition. Over here, it will calculate the radius for the first value. Sorry, it will calculate the volume for the first radius, 10. Then looking at the conditions, will go to 15, then 20, and so on. So, in certain situations where you want the statement to be executed at least once before the condition, then you use a do-while loop. We can also implement a for loop. In a for loop, we have got the initial value of our loop variable, the condition, and the increment value all in the same line. Okay? Remember, a loop should have 3 major aspects. The first thing, a loop should have a variable associated with it. Here the variable is I. Having said that, a loop should have an initial value. It should have a condition which tells how many times the loop will continue. Initial value is 0. I is less than 9. So from 0 to 9, that means it will go inside a loop 9 times. Finally, the third aspect of the loop is a loop should be told to increment the variable. If you don't increment the variable value will always be 0. Guess what happens if the value is always 0? 0 will always be less than 9. So this will continue as an infinite loop. You just created a virus. Okay? So you have to make sure that you increment your loop variable. So at some stage, I value will become 9. The moment I value becomes 9, then only it gets out of the loop. Okay? You have to get out of the loop. Remember, if you don't get out of the loop, you have just created a virus which is not efficient programming. So, while loop, do while loop, and for loop. Okay? In for loop, the initial value, the condition, and the reinitialization of the value is all in the same line. Okay? Now, which method and which loop do we use? Okay? Well, I told you, you can change the loop from one form to another. But usually, we use a for loop for fixed iterations when we know how many times we want to go inside a loop. And we use while loop and do while loop when we don't know how many times the loop will continue. Okay. Next topic which we studied was arrays, matrix, and structures. Arrays are special variables which have got a dimension. How do you mention the dimension? You put a square bracket and then you put the size of the dimension inside the square bracket. That's how the compiler knows that, hey, this program has got an array. Look over here. I have created an array called vector. The dimension of my vector array is 100. Now using a for loop, I can show the value inside it. Of course, this one will not work because I have not initialized the values inside my vector array. Okay, another example, I've created an array known as vector. Again, the size is 100. Okay, using a for loop, I'm going to show the value multiplied by 5. In the second for loop, I'm going to show the value inside the vector multiplied by 5 plus j. J value is also 5. You can do all kinds of expression. Now, in these two programs, we have not initialized an array. Array space is just like a variable. It needs to be initialized. It needs to have an initial value, which we are doing over here. You see, we are creating an array called vector. The size is 100. And now using a for loop, I'm saying that, hey, I want you to start from the 0 subscript until the 99th subscript. And every subscript, I want you to give a value of 0.0. Another thing you will observe, my dear students, I haven't used curly. There is no curly brace inside this. Opening curly brace, closing curly brace. You can do that. But that means the first line after the loop belongs to the for loop. Okay? The second line will not belong to the for loop anymore. That is why it is always beneficial for you to use curly brace. Always use a curly brace in your constructs, decision, or loops. In this program, we are multiplying two vectors. We are creating one array called vect1, second array called vect2, and a normal variable called result. And using a loop, we are calculating the value of result. We're saying result plus equal to, that means result is equal to result plus vect underscore 1 starts with 0, 0 times vect underscore 2, 0 subscript. Then it will increment and become 2. Sorry, it will increment and become 0 plus 1, which is 1. Then result will be equal to result plus vect underscore I value is now 1 subscript times vect underscore 2, 1 subscript. Remember, students, I told you this from the beginning of our session together before the lockdown. Always do tracing. You want to learn programming? Do tracing. Take a piece of paper, mention the variables, and draw a computer screen and see what will be shown. As in our previous sessions, I've taught you how to do tracing. So when you do tracing long enough, when you look programs at this, immediately in your mind, you can see the output and how the program will look. We can also have a two-dimensional arrays. You see, I just created the matrix. Okay, a two-dimensional matrix. X, Y. X dimension, Y dimension. The first for loop will show me my rows. The second for loop will show me my columns. Over here, I'm creating a two-dimensional matrix. Remember, in two-dimensional, matrix, which is a two-dimensional array. This represents the rows. This represents the columns. And now what am I doing over here? I'm saying, hey, I want you to initialize all the cells in this two-dimensional array to 0.0. It's a float value. Okay. So the first for loop will be for the first row 0. Row 0, column 0, initialize to 0.0. Then row 0, column 1, initialize. So first, it will start with a 0 row and initialize all the columns from 1 to 99. Then it will go back over here, increment 0 to 1. Then the first or the 1 row will be initializing all the columns inside it, and so on. Do a tracing so you understand it better. We can also transpose a matrix by creating a temp array, two-dimensional array. Transposing a matrix, if you remember, making our rows columns and columns rows. How do we do that? By using a temp variable and storing the value of the matrix, this matrix, inside temp. And then just flipping the value. Over here, you see, we flip the value. ij has been flipped to ji and is stored inside matrix. So what happens to the matrix? All the rows will be converted into columns and vice versa. The data structures that we studied are arrays and structures. I told you before, we have got many data structures in programming, but we limit ourselves in engineering programming to the two basic ones, which is arrays and which is structures. What is the benefit of structure? The problem with array is that when you have an array, it will only accept the same data type. For example, if I create a 2x2 matrix here, in other words, if I create a 2x2 array, all my values should be float. I cannot enter any other data type. But the thing with structures is you can. It makes your program much more sophisticated. Okay? Look here. I'm creating a structure known as line, and my structure is going to have integer variables x1, y1, x2, y2. So the name of my structure is known as line. So line is going to be a new data type that I can create a variable of. You see, line is my data type, and my variable name is line1. Now that means line1 can access the variables x1, y1, x2, y2. Why? Because it's a variable of line. It can access everything inside here. The only thing you have to remember is you have to separate it with dot operator. Line1 dot x1 can be stored in the x variable, and so on. So this makes structures very sophisticated programming data structure. Another example, you see what I'm doing. I'm creating a structure known as complex. Okay. The name of my structure is complex. Now I'm saying, hey, complex structure has got three variables, A, B, and C. So A can access real and imaginary. B can access real and imaginary. C can access real and imaginary. And that's what we are accessing it by using the dot operator. So every time you say C.real, that means it's a separate entity inside your memory. A.real is another separate location in your memory. So this is the sophistication of your structure. And they need not be the same data type, my dear students. They can be different data types, all inside the same structure, something that you cannot do with an array. This is how you create a structure, or you can use a typedef command to create a structure. And then you mention the name of your data type over here. And you create a variable of your data type. So here is your line data type. Remember, C programming language is case sensitive. Okay? It's case sensitive. So the moment I create a variable line1 of the line structure, that means line1 can access x1, y1, x2, y2. So another example, instead of creating a structure in the usual way, I'm using Typedef, and the same program, I'm creating a complex data type. Now, using complex data type, I create 3 variables, A, B, and C, and I say that A, B, and C are variables of complex. That means A can access real, imaginary, B can access real, imaginary, C can access real and imaginary. And every one of them, separated by a dot, is a separate location in your computer's memory. Now, I'm not so sure whether you have implemented structures inside your assignment. Okay, you can see whether it is necessary to do so. Next chapter that we went was functions. We studied functions in 2 weeks, functions 1 and functions 2. The issue was programming is very complex, consists of millions of lines of code. Putting everything inside the main function will drive a programmer crazy, will drive a analyst crazy. Analyst is the person who checks over the programmer's work. So what they do is divide it into small bits. Okay. Remember what Henry Ford did to automobile industry. He invented the concept of assembly line. Okay. And that drove the price of automobiles down. And then everybody could afford a car. Before that, having an automobile was a very expensive thing. Only the rich could afford it. But Henry Ford, because of the concept of assembly line, it drove the price of automobile down. And that was a new innovation. Now we take that assembly line to everything when we manufacture a product. And that brings down the price of commodities. And we can also take that assembly line concept and put it inside our code. Rather than having everything inside one function, divide it into multiple functions, which is also encouraged in your assignment. Let me remind you, it tells you have multiple functions in your code. Okay? Modularize the code, break up the code into multiple functions. Okay. We have system functions and we have user-defined functions. Now, in your assignment, if you have more user-defined functions by breaking up the code into different functions, it will make your program much more manageable. An example over here is, you look, I have got my main function and I have got my user-defined function. Usually, when we have a user-defined function, we have to declare it, also known as function prototyping. In this case, I don't have to declare it. Why? Because my calling function, which is the main function, you see I'm calling my function here, comes after the function definition. So no need to declare it. On the other hand, if my main function was coming before it, then I have to declare my function. You see over here, I'm giving the value to the SQ variable by calling the my_power function. So immediately it goes over here, passes the value of I to X, 2 to Y, calculates the value and returns temp, and the temp value is returned to SQ, and SQ has a value when I is 1. Then I becomes 2, and the same process continues. Every time it goes, it calculates the square of the number and returns it. So this program shows you the square of numbers 1 to 20. As I told you, if Your user-defined function comes after the main function. You have to declare it first. Remember, every function has got a return type, it has got a function name, and it has got arguments, also known as parameters. Okay? We also have system functions like printf and scanf, which have got special meaning in a program. Okay? In order to make printf and scanf work, we have to use a header file stdio.h. Whenever you pass array, remember, arrays are passed by reference. Okay? Maybe I will let you know again the concept of passing by value and passing by reference. Passing by value means, we studied this a few weeks ago. Passing by value means you pass the value from one function to another function. For example, in this example, if you see, when you pass the value, okay, of I, the value of I initially, which is 1, will be passed to x. So this is passing by value. If you put an ampersand over here, then the I value will be linked to x. Now that is known as passing by reference. When the x value changes, I value will immediately change as well. Okay, in this situation, we don't need to make it reference. That's why we make it pass by value. Having said that, printf always passes variables by value, whereas scanf passes input variables by reference. That is why in scanf, you use the ampersand symbol, which is the reference symbol. Ampersand means address of. Whenever you have arrays in your program, remember it is passing by reference. Now, whenever you declare an array in your function, because remember, you have to always declare your function, especially if your main function is in the beginning of the program. When you declare an array, you can declare it by mentioning it empty, mentioning a size, or just putting a indirection asterisk operator over there. There are 3 ways you can declare it. Look, over here in this program, I'm declaring my array, either empty, or I can put a value. As it says over here, I can put a value inside it, or I can just put an asterisk indirection operator. Now, look at this program. In this program, what we're doing is we have a function known as swap underscore vector. I have to prototype this because the main function, the calling function, comes before the call function. Now I create an array, size is 3, and the values are 3.5, 6.2, 7.1. Sorry. So what I do is, I say the original vector is 3.5, 6.2, 7.1. I show the value. Then I call the swap vector function. So it goes to swap vector function. It passes the value of vec1. 3.5, 6.2, 7.1 is passed to v1, my dear students. When you pass a value, these are passed by reference. So whatever happens to v1, the same thing happens to vec underscore 1. They are linked to each other. Now using a temp array, I switch the values. Okay, we did the tracing of this, my dear students. Please go and look at the earlier videos which I put on Moodle, so you can see how we did the tracing. Once we swap the value of temp over here, using temp, we swap the values of v1. The moment you swap the value of v1, guess what happens? Vec underscore 1 is also swapped. Why? Because it's passed by reference. Okay, and then it will show you the values are swapped. So when you declare a one-dimensional array, I told you, you can either declare it like this, or like this. In two-dimensional array, the concept is something like that, only with the first dimension. Remember, in two-dimensional array, first dimension is row, the second one is columns. So when you declare it in a function prototyping, you can either declare like this or like this. The first row will be blank. Or you can declare it in three-dimensional, you can declare it like this, or the first dimension you can leave as blank. Look at this example, function prototyping print matrix. Okay, sorry. Function prototyping print matrix. The first dimension of the row is left blank. Remember this program, what do? We give a value to our matrix. It's a 2 by 2 matrix. We give a value for all the 3 rows and 3 columns. And then we call print matrix. So it goes to print matrix. It passes the value of matrix to M1. So matrix is going to be linked by M1. Remember, whenever you are passing a value of array, it is passed by reference by default. Okay? And then using a loop, we are showing the values. In case of structures, it is always passed by value if you are not changing the value. If you're changing the value of a structure, then it will be passed by reference. Okay? Now, last topic that we studied was file inputs and outputs. What did we study about this, if you remember? It's very important for us to write to a file and read from a file, because a variable is not a permanent storage. The moment the program ends, or the moment power goes off or computer crashes, your variable data is flushed, it's empty. So in order to have a permanent storage, we need to store data in a file. Look at your assignment. What does it ask you in the beginning? There is a file called input.txt. You have to get your data from that input.txt. Okay? So similarly, we have to learn how to read or write to a file. Okay? Usually we write first and then we read. In your assignment, it tells you all the varied values that you get, you have to store it in a CSV file. Okay? In a comma separated value file. That means in a sort of an Excel file. A file in C is a sequential stream of files. So the first thing you have to understand, a file needs to first be opened. Okay? There has to be a pointer associated with a file. How do we create a pointer? Just like how you create a variable. Mention the data type and then mention the pointer. Just like this. Data type is file, pointer is asterisk, name of your pointer. Any name you want. Just like the variable naming rules. Just like the function naming rules. Should not start with an alphabet. Should not start with a number. Should always start with an alphabet. Okay? Just put a asterisk before it. So here I'm creating a file pointer. Here I'm creating a file pointer. And the file pointer will always point to a file. You have to link your file pointer to a file. And the file pointer will always start with something known as BOF, beginning of file, which is the first location of the cursor. And once it reads that, it will keep on moving to the next line, until it comes to the EOF, end of file. So you have to associate your file pointer to a file. And then you have to say, are you opening it for reading or writing? Which you have to do in your assignment as well. You can test if your file exists or does not exist. How? By using this code. I'm creating a file pointer, and then I'm associating my file pointer with a file known as my data. I'm opening it in the read mode. And then I'm saying, if my file pointer is null, that means the file my data did not open. Or you can say my file does not exist. Just take this code and implement it in your assignment. It is a new feature if you haven't already done so. If the file does not exist, it will show that the file does not exist. Else, if the file exists, then it will do something else. Okay? That's why I kept on telling you that this assignment, the more you think, the more you think about it, the more hours you give it to you give to it and perfect it, the better marks you get. There is no such thing as a perfect assignment. You can always make it better and improve it. That's what, as I told you many times before, that's what makes a difference between a good student and an excellent student, as far as your assignment is concerned. When you read from the keyboard, you use scanf. When you read from a file, you use fscanf. Okay? For example, over here, what I'm doing, I'm reading from a file. I'm creating two variables, A and B. I'm creating a file pointer known as fptr1. And then I'm saying, open my data in the read mode. And now I want you to read. You see, I'm associating. You see, fscanf, that means read from a file, associating with the file pointer. This file pointer is associated with my data. So it will read my data. There's something wrong over here. What's wrong, my dear student? I haven't mentioned the extension name. This has to be .txt. You cannot just write a file like this. You should have an extension name. Okay? So I'm associating my file pointer, which is associated with this file, and I'm reading the values from this file. The first value will be stored inside A. The second value will be stored inside B. How do you know which is the first value, which is the second value? You have to separate the value with a space bar, or with the enter. So in your assignment, your input.txt, how will you separate the values inside that? Put a space, for the first value, put a space for the first reading. For the second reading, put the enter again, it goes to the new line. I'm not supposed to tell you these things, I'm sorry. The fscanf function reads values from the pointer to by fptr. So here, the file pointer points to this. So the fscanf means read from mydata.txt. Similarly, we have got fprintf. Fprintf means write to a file. Okay. This example we went through, what I'm doing is I'm creating a file pointer. We did tracing on this. So I'll just go overall on this program so that perhaps you can remember what we discussed. If you forget, you can always go back to the video file and check it out. Now I'm saying that the file pointer is associated with my data. Again, .txt is missing. My data.txt, open in the read mode. So read the first value and store it inside number. The first, remember, the cursor starts from BOF. 5 will be stored inside number. Why 5? Because there are 1, 2, 3, 4, 5 rows. Okay? Now look in your assignment. How many rows do you need? In your assignment, you need how many rows? Only 2. Forgive me. What? How many? Look over here. 5 means it has to go inside your number and store it inside your number variable. Why 5? Because 1, 2, 3, 4, 5. And every value is separated by a space. So 23 and 75 will be stored In the for loop, we see starts here, ends here. 23 and 75 will be stored in A and B initially when I is 1. And then it will show. When I becomes 2, then the cursor has gone over here. 92 will be stored A and 102 will be stored in B. Okay? What I'm trying to tell you, my dear students, this is very similar to your assignment. But rather than implementing it in this way, it would be better for you to implement it in this way. In this way, without mentioning the 5 in the beginning. Then the question is, hey, if I don't have a 5 in the beginning, over here I've got 5. That means I want to go inside this 1, 2, 3, 4, 5. If I don't mention the number of rows in the beginning, how will my program know when to stop? Very simple. Your program will keep on reading until it encounters something known as end of file. How do we do that? We use a function known as FEOF. Okay? FEOF will show you end of file. There are two ways you can find the end of file. First is using fscanf, okay, using the pointer to read the value. And then you can say if FEOF has been encountered by the file pointer, then that means you have encountered end of file. Or you can create a separate variable. In this case, iStatus is equal to fscanf fptr. If iStatus is the same as EOF, we have encountered end of file. So you can implement this inside your assignment, either like this or like this. So remember, I told you this one, you can solve it without mentioning the number of rows in the beginning. How? Look, here there's no rows mentioned. So associate the file pointer mydata.3 with the fptr file pointer in the read mode. Now we can say, hey, iStatus is equal to fscanf. Keep on reading. 23 and 75 will be read. And then I ask, hey, is iStatus the same as EOF? No, it's not. Because it has not encountered EOF. When it reads 23 and 75, it comes over here. EOF is over here. So it will keep on reading until it encounters EOF. So this loop will continue until iStatus is not equal to EOF. Okay? That's why I keep on saying your assignment is actually very easy. It's not that complicated to do. Because you can get the ideas right from your files, examples that they have given you. Okay? You can also write to a file. The only difference is instead of instead of R, you have to write W. That means open my file in the write mode, and then you can write to your file. Okay? The pointer is associated in the write mode with the file. Again, I made a mistake. I haven't mentioned the extension name. So I have to write results.txt or results.csv or whatever. After you are done with your file, don't forget, you have to close your file by using the fclose function. Now, there is another aspect to your assignment, which I will let you know here. You have to also create a CSV file. How do we create a CSV file? We have to write, okay? And we have to say, for example, results.csv. Look at the example that we have gone through in your previous lecture session, how we created a CSV file. And you have to generate the results for your CSV file in separate increments. Okay? I created a CSV file as per your example right on the spot. This is not exactly rocket science. This is very simple to do. And I'm sure that most of you have already done this. Okay? This brings us to the end of what we have studied in our engineering programming session for the past one semester, and hopefully you have implemented all this inside your assignment. Now, I think if you have any questions, you can ask me. Anyone has any question?
Sir, I got a question.
Yes.
All right. For the test criteria, is it supposed to be made up by the programmers, or is it based on the test cases?
Based on the test cases. But there is something else about the test case. Remember, what if the user enters a value which is a wrong value, right?
Yeah. So that's why, like, I'm thinking, if the test criteria is based on the test cases or it's based on the programmer. So if it's based on the programmer, there'll be like, I'm thinking of good data, bad data, or like just incorrect.
Yes. So have a bad data and show what your program does with bad data. Get it?
All right.
Yes. In programming, there is something called exception handling. There is actual code related to exceptional handling. By that I mean there are special blocks in programming. We study try, catch, and so on. But it's beyond your course. You haven't studied this. If you do computing, you will study all those things. But you still can implement exception handling by using your decision constructs, correct? That means if there is a range of value which does not belong over that, then just give an instruction, have an exception handling. I won't tell you how to think or how to do. That is what makes your program unique. And that is why there is no instructions, detailed instructions about your report, because the student can perhaps implement like what you just said. I think I've given you a lot of tips about your assignment today. Anything else? We have got a student called Batman. I didn't know Batman was my student. What about Robin? Do we have Robin? Any other questions, my dear students? Remember, assignment 60%. So, and it's not difficult, it's very simple. We just went through some of the codes and I gave you tips related to your assignment. Okay. So please make sure that you do well for your assignment. And today I checked the assignment. Some students, I think 5 or 6 students have already submitted the assignment. I haven't checked what they have done. I will check it by weekend, I guess. This is a very unique opportunity, my dear students, for all of you. It's very it's very unique. Why? Because you are not asked to sit in an exam, midterm or final, and write code. In your case, you have to actually refer to an open book. Just understand the concept and do a project which implements your understanding. And it's a good opportunity for you all, whereby you can easily get good marks as long as you follow the implementation of your assignment. So simple, I think. Okay. Any other questions? If you don't have questions, sometimes it's scary when students don't ask. You know why? When the assignment was released, nobody asked me anything. The questions start coming since, I mean, 2 weeks ago, there were students asking, but since 1 week, my email is flooded with questions. You know why? You know why? Because when the students start doing the assignment, then they ask, how do I do this? How do I do that? So some students who are not asking questions, I'm scared they haven't started the assignment even today. My dear students, if you haven't started the assignment, please start it right now. The moment we stop this call, start it. Okay, you can still do something with it. Okay, and if you have any questions, you can still email me. I will answer you. Okay. Thank you very much for your attention. Wishing you all the best. And it was very nice uh, going through engineering programming with all of you. You are the last batch for engineering programming. The next semester is going to be Python. Okay. Uh, I'm sure that if you go through all the lecture slides, both per and whatever we have discussed online over here from the video files, you will do well in your assignment and get a high score. Above 75%. Okay. If you,
So,
yes, question?
can you explain the part about input again?
Uh, the input as your lecture, as your assignment says, I have your assignment right open over here. Okay. It says that your input, you see, where, yeah, programming tasks, read from an external file. Name this file input.txt, which stores the input values for the pipe diameter. Pipe diameter, space, pipe length, space, fluid velocity, space, fluid density, space, and fluid viscosity. Get it? You have to store the values inside the file input.txt, and your program should read from that. Okay? Then
Yes.
you understand the concept, right?
Yeah.
Okay, now rest. I cannot reveal everything to you, right? Next, you put two and two together and try and understand the concept. Okay? Inadvertently, while teaching you today's revision session, I told a few things about your assignment which I shouldn't have. Okay? But anyway, it's okay. I mean, it's not a big deal. I'm going to take this session as well and put it as a video on Moodle. Please go through it for your final revision before you submit your assignment. Okay? The assignment is very crystal clear. The only part which is not clear, which I have already told you in yesterday's forum post, is your report section. That's why many students ask me about report, and I answered what I expect to see, okay, in your report. A picture of the picture of the input files and the values, and what is the output of your program, and the output of the CSV file for both the values. Okay. So read your assignment document. For those of you who haven't started yet, I don't know what to tell you. Please start today itself. Today is 27th, 28th, 29th, 30th, 31st, 1st, 2nd, 3rd, 4th, 5th. And 5th, 5 p.m., you cannot submit it anymore. You have to submit by 5th, 5 p.m. So that would be, I guess, less than 10 days. Please do your assignment if you haven't started it yet. Start today. And remember, once you are done with this unit, once you do the assignment and submit it, you don't have to worry about the final exam anymore. It's done, finished. Okay, 60%. It's worth 60%. And remember what I told you. Do not allow anyone to see your assignment code. Do not share, because you don't want to be in trouble as far as plagiarism is concerned. Dr. Tan has given me a file about different kinds of plagiarism, which I'm going to also upload it to Moodle, so you can have a look at that, just to make sure that you won't be accused of plagiarism. Okay? Any other questions?
So I have a question.
Yes?
When doing the assignment, is it a must that we have to change the variable name when using pass by value or reference?
No, depends on you. If you want, it's
Okay.
okay. If you don't, it's okay as well. No big deal. You can have the same variable names, but remember, if you have the same variable names when you pass, wouldn't that confuse you as a programmer? If it's confusing you, then have different names, right? And you know, one of the tasks in your instruction is make your program readable. So have different names so that it removes confusion. Okay? Anyway, I leave it to you. I mean, it won't affect your marks if that's what you're asking. Same name or different name? No. Anything else? Okay. In case you can think of any questions, anything else, please email me. I will try and answer it without giving you, explicit tips. Don't ask me explicit questions, because I cannot give you explicit answers. Then everybody's code will be the same, right? So if you're really confused, actually there shouldn't be any confusion. The only confusion was with the report section, and I've clarified it already in yesterday's forum. There shouldn't be, but still, if you have any questions, please send me an email. If you still have issues, then perhaps we can do a WhatsApp video and talk to each other like some students. But I don't think so you will have that problem. Most of you are pretty well versed. And I've already checked before I came here, 5 students have already submitted their assignments. So that shows that your batch is really very confident and well versed. This 2 things I want to tell, which I say every semester. This is the best batch I've ever had in programming, and I say that every semester. So best batch or not, this is really unique. We never had an assignment for engineering programming. It was always exam, especially written exam based. Your batch is really lucky, okay, because of the lockdown and being isolated and studying. But we still managed to make something out of it. Okay, hopefully your assignment reflects the things that we have studied. Looking forward to a good work. Mr. Suresh and I are looking for a good work from all of you. Okay. Any other questions? If not, wishing you all the best. And hopefully this semester, our passing rate will be 100%. Thank you very much, my dear students. I will disconnect now, and you can concentrate on your studies and whatever you're doing on your assignment. Thank you.